Let's do one more, and this one involves some negative exponents. This one has 2 minus y minus 6 to the negative 1 equals 6 times y minus 6 to the negative 2. This one's a little jumbled up, so it's kind of difficult to figure out what we should swap out. It is good to know that we do have a y minus 6 that seems to be common, so that'll be part of what we end up exchanging with u. Let's go ahead and get everything onto one side. I'm going to move everything over to the right side. So 6, y minus 6 to the negative 2. I will add a y minus 6 to the negative 1 minus 2. Okay. Now, what I'm really recognizing here is that this negative 2 is exactly twice as large as the negative 1. So that's a pretty good indication that I will end up swapping out my u for this piece right here. So let u equal, let's call this y minus 6 to the negative 1. Okay, not bad. All right, now let's go ahead and rewrite our equation using this. So we have 6u squared plus a u minus 2. Okay. So what I can see here is that it's definitely quadratic and the numbers are much smaller, much nicer to deal with. But really, what do I do from here? I still have to be able to figure out what the solutions of this quadratic are. So we got lots of tools available to us. Let's go ahead and try the quadratic formula. Why not? So negative b plus or minus the square root of 4. Negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. All right, I think this will simplify nicely. So I have 4 times 6. That would give me a 24 times 2, which would be a 48, all over 12. Or negative 1 plus or minus the square root of 49, all over 12. Or negative 1 plus or minus 7, all over 12. So u is equal to a negative 1 plus 7 over 12. And I have u equals a negative 1 minus 7 over 12. So let's see, negative 1 plus 7 would be a 6/12. This would be a negative 8/12. And both of those reduce. This one to 1/2. Let's see, and the other one, 4 goes in the top, 4 goes in the bottom, negative 3/2. So now I know a little bit more about what u is equal to. Okay, but of course we can't stop there. We must go back to our original variable. We must work back all the way to those y's. So let's put those back in for u and see if we can solve this from here. Let's see, y minus 6 all to the negative 1 equals 1/2. And y minus 6 to the negative 1 is equal to a negative 2/3. All right, to solve this from here, I think I'll raise both sides to the negative 1 power. That'll give me a y minus 6. And then with that negative 1 exponent, it'll change the location of the 1 and the 2. So 2 over 1. Let's do the same thing with our other equation. So raise both sides to the negative 1. So it'll give us y minus 6 equals a negative 3/2, since it changes the location of the negative 2 and the 3. Okay, these are almost done. With the one on the left here, let's add 6 to both sides. So this will give us y equals 8. And with this other one, again, let's add 6 to both sides. So negative 3/2 plus 6. Okay, looks like we do have to get a common denominator. But this one's not so bad. Looks like it is just 9/2. And now that we've worked all the way back to our original variable, now we know what the solutions are. So it can take quite a bit of work to end up swapping out the u and solving from there. The important part is, though, that if we don't swap out the u, we don't really have a whole lot of other techniques to solve equations like this. So make sure you properly identify what u you need to swap out and put it back in so you can get back to your original variable. Thank you for watching Educator.com.